All right, good evening, everybody. Thank you all for coming to the NASA Hyperwall. I know it's not just all about the books, right? Everybody's here to learn something. So, thank you for sitting and listening to this. I'm just here to give an overview of what we do at Earth Science at NASA. And a lot of people don't know that NASA has an Earth Science division. And what we do is, next slide, please. We use the unique vantage point of space, currently our 23 Earth observing satellites, to look at different properties of our global world. Some of these are focused on the biosphere, some of these are focused on the cryosphere, and we can study many aspects of the Earth system. And at NASA, we use this information to explore, and that exploration leads to discovery, which leads to research. So our overarching goal is to understand and protect our home planet for societal benefit. Next slide. So I just want to give you an overview. Since Earth Science at NASA is about to turn 50, we started to talk about some of the major highlights of our findings, both basic and applied research over the years. And what we realized in doing this is that some of what we do, some of the images we're able to project, some of the predictions we're able to make with models actually look somewhat like artwork. So we can do things like make basic research observations of aerosols and different types of aerosols and use them and feed them into climate and weather prediction. And that's what you're seeing here. So this is a simulation of aerosols during the 2017 hurricane season. You can see a number of different aerosols on the bottom. You can also track the hurricanes by name. Next slide. And so one of the most iconic stories, I think, to come out of NASA and out of science in general was actually detailing the hole in the ozone layer in the 70s and how this led to things like the Montreal Protocol and actually led to doing things like monitoring the progress of the recovery of the hole in the ozone layer, which is very important for shielding Earth from a lot of harmful radiation, and how the effect of the Montreal Protocol led to its recovery over time. And it's been relatively stable since the mid-1990s. But I think satellite data are absolutely critical in getting that global observation. And when coupled with in situ observations, no matter what aspect of the Earth system properties we're looking at, it's very important for giving us motion forward scientifically. Next slide. So one of the other, I think, truly iconic animations and something we're able to detail over time is looking at changes in ice cover at the poles. And this shows you the annual Arctic sea ice minimum starting in 1979 with the graph that overlays and shows the big drops over the last 10 years. And so to be able to track this change over time allows us to not only explore spatially, but temporally. Right? So what we're able to do is identify changes in long-term trends in our climate. Next slide. Thanks. So the other animation I like to show is 20 years of Earth's biosphere. Now, if you know anything about biology on the Earth, it supports a tremendous economy worldwide, both on land and in the ocean. And what I like about this animation is it's like watching the Earth breathe. Okay, you can actually see many changes over time, and in addition, you can actually understand the impacts of atmospheric phenomenon on our land and on our oceans. Next slide. So one of the other pieces that's very important, and in 10 minutes, I don't have enough time to show you all of what we do at NASA, but taking this time series of information, all of the spatial information, all of the temporal information, and actually using it for a predictive capability is really important. And so this is a GEOS5 model run, different properties shown in each panel. And it can be used to look at changes in the atmosphere and those impacts of the changes in the atmosphere on the rest of the Earth system over time. And this is a constantly evolving animation because we initialize the models with actual data and then can use some of it to do hindcasting and forecasting. Next slide. So the only thing I think what's really unique at NASA is not only having the research programs embedded with some of the satellite information, but we also do applied sciences, okay? And that means we take all of our research findings, all of our research data products, and try to transition them into the hands of managers, conservationists, and we listen very closely to see if there's something that they need that they're not getting that we could actually produce. And so one of the things that I think is important to look at over time is not only the coverage and recovery of things like fires, and this is Yellowstone, but actually looking at the lasting effects of things like wildfires and actually feeding that information forward to firefighters as things are going on. So this is the burn recovery in Yellowstone, and you can really see how some of the fires cause scars that take a long time to recover, if at all. Next slide. Thank you. So one of the other things I thought was really unique to show was some of you may remember in 2018 in Hawaii, there were a number of volcanic eruptions for a good chunk of the year. And so what you're seeing right now is sort of the before picture, before the Kilauea eruptions of 2018. And then you'll see some thermal imagery that shows you the actual eruptions. And then you'll see another Landsat shot that shows you what the area looked like after. And we can feed this information forward to managers on the ground and policymakers. It can be very helpful in their planning for the future and their recovery. So while we don't really do any management or policy making at NASA, a lot of what we do is policy relevant, and we're constantly looking for those synergies. Next slide. Okay, and so I love this one. This is actually GPM data, and I remember one day this summer, there was a horrific day of rainstorms in Washington, and it just so happened that GPM was passing over, and we were able to capture in the Washington, D.C. region this horrible deluge of rain that left us with like 4 inches of rain in one day. And so Gail Skowronek-Jackson, the GPM program scientist, said, we happen to catch this. And she fed this one forward. And I think Thomas Zurbuchen tweeted it out that day. And we just thought it was what a chain of events to actually capture the local real rainstorm and get a picture of it from one of our Earth observing satellites. And of course, one of the things that NASA does is feed a lot of this information into weather prediction. Next slide. Okay, so it's your planet, right? We're turning 50. It's one of those things that you say, well, there are a lot of things that we could still do. And we're always thinking about that. We have a lot of new missions in formulation and a lot in development. And I know around the corner, a lot of you have queued up, next slide, for what we call our new Earth at Night book. And just because the Earth is dark doesn't mean there aren't things going on that we can measure and understand. We've actually used this Night Lights product and fed this information forward, not for just managing recovery from natural disasters, but also doing things like tracking illegal, unreported, and unregulated fishing. So these images, even at night when things look serene and very quiet, can be very useful for our science. So with that, I will say thank you. I hope you all stay here and learn something more about Earth science at NASA.